Okay, so I would like to do a quick presentation on the recent developments in Tangra to do with the mutual event support and the ADV file format. And the ADV format has been created as a file format from the ADVS system to store video in 12 and 14 bit, and it has been used for a while already, almost 2 years. After the feedback that we got from various people, and after being able to work with the file format for a while, it is now in a stage of actually creating a new version, which will be backwards compatible, but it will be better. And I would like to tell you a bit more about this as well. So from version 3, Tangra is able to handle 2 new file formats, which are the ADV, which is the ADVS system file format, and another one which I call AAV, which should stand for astronomical analog video. And this file format is recorded by the Occult software, which I'm going to cover as well a little bit. So a bit more about the ADV file format. When we created this for the ADVS system, we wanted to come up with a file format which, so first of all, we needed a new format because we were about to store 12 and 14-bit video, and the standard AVI files wouldn't support this type of thing. We also wanted to create a file format which will store some extra metadata to do with the images being stored. And we were influenced a lot by the FITS file format, which is pretty much file format for storing individual images with extra information, such as the coordinates of the object being observed and other information. So we created a format which is like a stream of FITS images, but a little bit better because we also made it possible to compress the information, while storing individual FITS files wouldn't allow us to do something like this. And when Tangra opens an ADV file, what you can see right now on the screen is all this extra information which is being stored with all of the video frames. And on the top, you see the metadata for the whole file, which includes things like camera model and recorder, width and height of the video, etc. While the other part of the screen, you see the individual information for the frames. So is the sound all right? Should I just keep going? Okay. So what you can see is the additional information which is stored with every video frame. And there's things like the video camera frame ID, there's various GPS flags, like whether there is a GPS fix, how many satellites are being tracked, all those sort of things. So as you can see, this is a pretty comprehensive file format for storing video frames. With the new version of ADV, which is being developed right now, a couple of things we wanted to improve was, first of all, coming up with a good compression. And for it's really good news that the author of the lossless compression or the actual codec for 8-bit video agreed to develop a 16-bit lossless compression for us. And he's already done this, and he has donated his code to our project. The other good news is that while the ADV version 2 is being developed, we also managed to bring over a number of people which were previously working on another file format for 16-bit video called SARE file format, which is very popular in planetary observations of planets. And while it can store 16-bit video, it's not very good with storing of the metadata, including timing of video frames and etc. So the new ADV file format and everything else which is required to record an ADV is actually an open source project which is already running. And if you go to this place on GitHub, you can find all the current C# and C++ libraries for anyone to be able to store in ADV. And it's also good that other software, not just the ADVS, was also decided to adopt the ADV file format. The other one, which I mentioned that Tangra supports, is the AAV format. And I would like to mention a bit more about this. The idea pretty much is to improve the analog integrating video camera recording, where if you, for example, running your camera in 8-frame integration, instead of recording 8 frames, which are pretty much exactly the same, but probably would have different noise, we just record one single frame. And by doing this, first of all, we remove a little bit of noise, and second, we manage to decrease the total file size. And I have my software called Occult, which a number of people use, including Brian Lauder in New Zealand, to actually record with their analog video cameras. And this is pretty it works. This is my choice of recording my own occultation videos in the past year or so. So other new features in the new Tangra include, and I know that some of you probably have seen them because it has been in a beta version for a while, but I just want to go through them quickly, is the IOTA-VTI timestamp OCR engine, which reads the timestamp of the screen. There's a new tracking engine, which is quicker and works better in the standard case, where there's no strong wind or any other issues with the video. There's a number of display mode enhancements which I'm going to show you. There's the integration with Occult's AOTA for extracting times of events directly from Tangra, which also integrates with Occult Watcher, and you can actually pre-populate your report in Occult Watcher. And there's the new mutual events reduction, which I created for the next season of Ukrainian mutual events, which includes overlapping object fitting, a simultaneous fitting of objects. It also includes an improvement to the background fitting by trying to model the glare of Jupiter if the satellites are close to it. And finally, I also added a thing in the light curves where stellar magnitudes can be calculated directly from the light curve. And I'm going to show you one by one of the new features. So first of all, OCRing a timestamp is a really difficult job. That's something I can tell you. And it's really well done for a line movie which supports 3 different types of timestamps. The Tangra 3 only supports the AOTA-VTI, but it supports it in any screen resolution and screen aspect. But the important thing is, and this is not immediately obvious to anyone, for this to work, you must have all of the video fields in your video. And I know that there's some frame grabbers which duplicate one of the fields twice, or in some cases skip fields. And if you have such a video, Tangra will not be able to read your timestamp. And this is purely because of the way it recognizes the digits. All of them must be present, and all of them must be inside the actual video frame. The new tracking engine, as I said, those of you that use the old version of Tangra know that if you have lots of flickering and wings and other issues like this, the Tangra is very capable of tracking your video, but at the same time, it's so sometimes it's very zealous, if I can say that, for what it considers a good point of the stars. And if you don't have really wings, sometimes it may mark some of your stars as not successfully tracked, because it really wants to find a very perfect match of your stars. And what I created here is a new tracking engine, which is called simplified tracking. This is what I call it, which is much faster and works really better for the normal case, where most people observe with no wings and no significant flickering or clouds or stuff like this. The other enhancement, which is the display modes, is especially useful for the new 12, 14, and 16-bit videos, where it's very difficult really to see stars or to see the difference in intensities in different areas of the screen just by looking at your 8-bit grayscale image on the screen. So that's why I created a number of enhancements which can be chosen from the bottom part in Tangra, and this includes the so-called hue intensity, which pretty much displays the different intensity with color rather than with different shades of gray, because our eye can recognize much easier different color compared to whether it's darker or lighter. And the other option is the gamma. And when I say gamma here, I mean that the gamma is only applied to the video display. This is not applied to the actual data. So when you measure your stars, even that you have selected a gamma enhancement to be able to see your stars better, the actual gamma is not applied to the raw data. And in this case, you can see a very dark video in the top left corner, which is an ADV file recorded with 14-bit video camera, where the two stars are really dim, but they're simply dim because compared to the full well of 16, in this case 14-bit intensity, the stars do not reach higher, and that's why they're difficult to see. But as soon as you select a different gamma, they become very easy to see. The other very interesting and important feature is the work which I did with Dave Harold to make it possible this AOTA add-in to be called directly from Tangra. So when you have a light curve, there's a new menu item under add-ins where you can extract event times with AOTA, and Tangra will automatically send all of the light curve information, and AOTA will run everything else after that, returning back the extracted times of the event, and those times can be sent to Occult Watcher later on. And pretty much the way this works is you open your light curve in Tangra, then you trigger the AOTA add-in, then you do everything else in AOTA, and I'm sure Dave Harold will tell you a lot more about this after my talk. Then you can save various files from there, like the actual screenshots from the event if you want. And finally, after you have selected your event, and you can verify the event times as well by having a AOTA tell Tangra to move to a different frame, so the user can verify that the timestamp on that frame really corresponds to the timestamp which IOTA believes this frame should have. So finally, when the user is satisfied that the times are correct, when they say OK and they exit with the selected event times, then Tangra will save a small XML file in the same place where your AVI or your other video file is, which will include all the timing information extracted by AOTA. And this file will be made available to Occult Watcher. So if you have announced for this event, and if you right click on your station and go report observation, and when you pre-populate your Excel form, and at this point this only works with Excel, so it works for observers in United States and Australia, because in Europe they use text forms. So if you use the Excel form, you can actually choose and ask Occult Watcher to automatically pre-populate your form, which includes everything. Includes the instrumental delay, the errors, the error bars, the events, everything, which is a really excellent way of making sure that the user doesn't make any mistakes when they enter the data extracted from the event. Now moving to the mutual events. This was another big work for me, which I did in the past couple of months, and my intention was to make it easier or better for people to extract light curves specifically for mutual events. And there are a number of challenges in this case, which include things like there are not too many comparison objects, which means that if you're observing an occultation, for example, this is two of the Jupiter satellites already, and if the other two are not visible at the time, this is really bad luck. But if the other one of the other ones is visible, they may be either too close to Jupiter, or they may be too close to each other, which would make difficult the actual measurement. And in this case, what I did was I made it possible to fit a model of PSF point spread function, the actual Gaussian distribution of a star of two very close stars, and this is done simultaneously at the same time. So if you have okay, that's something different. The other thing I did in order to verify my measurements, that where I'm actually measuring is correct, I built an entire engine of generating test videos, which are controlled model videos, where you can ask Tangra to generate a video for you with stars with various magnitudes, and also with a close pass-by simulation of two objects. And you can also ask Tangra to generate a moving 3D polynomial background, which will generate an interesting video. And when I did that, it was very useful for me to verify that all the measurements in Tangra are correct. But once I finished with it, I realized that this actually may be a very interesting tool for other people using different software or using different ways of reducing their video to actually test the entire process of extracting light curves, extracting photometry from their videos. So I decided to make this public for everyone to use, to actually generate videos and try to see, when they measure them, they will know what sort of results they should get, because the video was generated with those parameters. And if I go back to how the mutual close targeting works, so if you have in Tangra two objects which are too close, and in this case these are two of the moons of Jupiter, when you click on them, then Tangra will automatically detect that there's too close, so they overlap, as you can see from this image, and it will automatically fit the model of the joint PSF, and that's what it does. And it can, so in this case, Tangra can make pretty precise measurements, even if the objects are really close. So my testing went up to 3 pixels, or even a little bit less than 3 pixels from each other, and it was able really well to measure the light from the objects. And I just want to say one other thing, which was a note from some people, is that the Juvenian satellites are actually not stars, and this is true. So, which means that the point strength function is not perfect, or which means that they have a non-ignorable size. However, if you don't use a very big zoom, then they're still like stars. They still behave like stars. So the measurement should be really correct. And I also tested this with real videos from the last season of Juvenian events. And the other one was the 3D polynomial background modeling. The whole purpose of this was to try to model the glare from Jupiter when one of the satellites is really close to it. And in the settings, there's now this new option where the user can choose whether they want the first, second, or third order polynomial to be fitted, and you pretty much choose one of them. I think that in most cases, probably the second order will work all right. So I've tested this really well against my model videos, and it works well. I had a very limited number of videos where one of the satellites was really close to Jupiter, and it really had some effect from its glare, but it hasn't been extensively tested with real videos. The other thing is another enhanced display mode, which is the I call it a background glow mode, where if you have selected your objects and you choose the background glow mode, Tangra will actually show you what's the shape of the background close to your satellite, so you can actually tell whether there's a real need to use a 3D polynomial background fitting or not. And in this case, the upper image, you can see that one of the satellites is really close to Jupiter, and even that the background looks really dark, you can see that in the hue intensity mode, there's a big change in color close to the satellite, which means that there will be certainly an effect from the background node. So if you're using a difference averaging algorithm, it may not work that well. So in this case, the 3D polynomial will probably work well. And that's some real light curves from my model videos, where you can see that as one of the satellites is passing very close to the other, and that's only 3 pixels in distance, the light curves of the two objects, which are measured individually, became pretty much the same. And this video also has generated noise in it. You can also tell Tangra to do aperture photometry, and in this case it's using an aperture which is large enough to have both the satellites in it, which is the second light curve at the bottom. The last improvement, which is, as I mentioned, is the ability to measure magnitudes. And I should warn that you should only do this, or you should only expect to get some sensible results from this if you, first of all, are not using any gamma in your. You have proven that you do not have any gamma in your system, and then your video is really your sensor is linear, and ideally you have applied flux and etc. But in this case, I've used this against my model video just to confirm that what's been modeled. So what I measure is exactly what's been modeled. In order to enable this, you need to go to the settings in Tangra, and then once you've enabled that option, there's this small M button which appears next to the light curve. And if you click it, you can set the magnitude of one of the stars, and then Tangra will automatically calculate the magnitudes of the other stars and show them at the bottom as well. So pretty much this was it, a quick overview of the new features of Tangra 3.1, which I've released early today as an official release. The project is an open source project for contributors and researchers. It has a license which is very similar to the AdvLib license. If any of you is familiar with the license of AdvLib, which they call a silenceware license, which pretty much means you can look at the source code if you want to verify something or if you want to contribute to it. And finally, it's a cross-platform software which also runs on Linux and Mac. And those of you that may have seen my presentation a couple of months ago from Melbourne, I actually demonstrated live Tangra running on Linux. And pretty much that's all for me. Are there any questions? Okay, just waiting for the questions to arrive. I can't hear anyone, so I don't know if it's my speaker's not working. Is the Tangra IOTA form all populated? It is pretty much all populated, yes. The only fields which are not populated are the ones where the observer chooses the clouds or other, whether there were other things which were unknown. But everything which can be extracted from the measurement, including error bars, and which was the event, because pretty much Occult Watcher knows which event you observe, and the Tangra and IOTA knows everything about the actual extracted event, including when did you observe from. So all this is populated, yes. You should certainly try this. It makes your life very easy. So what that Tangra does in regards to the record start and stop time, when you measure a video with Tangra, when you open up a AVI file or another file, doesn't matter what's the file, you can only measure part of the file, say from the 5th minute to the 10th minute, but actually your whole recording may be 20 minutes. The Tangra actually knows this, because when you open your video, it knows when your video starts and when it finishes, and it knows that you only measured a part of your video. So it actually saves in the XML report when your video starts and when it finishes, and it saves when you started your measurements and when you finish your measurements. So all this information is indeed filled in the form. Okay, thank you.